Hello everyone and welcome back to yet another video on this AutoGrad series from scratch. So guys, today I just want to show you something very cool, which I can call something that we have achieved so far. This is a kind of achievement that we've made together, and I use the word we because you were with me all the time. Whoever is watching, whoever is supporting, thank you so very much. So I just wanted to show you something very important, and this is our achievement so far. So I just want to go to this repository of mine, which is our framework that we're building right from the scratch. And if I want to go to the branch called Graph Validator, and I've pushed something very, very important yesterday, and let me just show you what that is. So if you want to come here, you will see these two files, graph.dot, which is actually the dot file of this graph, which we've made for our tensor framework, the transformers framework. So basically this graph shows that whatever we've implemented so far, so basically this connects each and every tensor with the previous, or with the next tensor, with the previous tensor, which is important for our framework to for the backpropagation, right? So let me just go ahead and open this file for you, and you see this a huge graph. And I can also open, by the way, here in terminal. So xdt open this thing, open graph dot png, right? So we've managed to create this graph, man. This is a huge success right now, and I just want to give you a overview of this graph for now. So what it does basically, so all the way here we are starting right from this very left tensor, and this is actually our x tensor, and x tensor means that we have token IDs converted to embeddings, right? So consider this embeddings. We can later just use Python to just create the embeddings from using from the text. We'll write a separate interface for this framework because we cannot do everything in C, right? So the idea is like keep C as much as possible, like 90 to 95%, but for 5 to 10% we do need Python for the interface, or something like that. So this is our initial tensor, and you see all these operations names, and these are all the tensors, right, representing some operation nodes or leaf nodes, right, which we've built in the previous videos. If you were with me, or if in case if you haven't watched them, I just do recommend you to watch them, because it took me a lot of debugging and brainstorming and head scratching to get to this point, right? So this is actually you can see these are two parts. So let me start off with like we've implemented so far multi-head attention and layer norm. So multi-head attention computational graph, if it works fine, is actually the most fundamental and most crucial layer of transformer. So if you get that right, the rest of the things are just the byproducts, or easy comparatively, comparative to multi-head attention, right? So I'm just gonna start off from here, all the way here, right? So you can see we have operation add over here, in case if I'm able to show you, I don't know. Okay, so let's just start from here. So we have op add, this is some operation add, and we have some scaling operation, we have some division operation, we have some square root, we have some op add. So it looks like that sequentially we are running tensor operations on some tensors, and and you can see that expand columns, when we have to expand the columns, when we take mean, or we shrink down the entire row to one single floating point value inside the tensor, and we need to like expand those columns in order to like match the dimensions for other tensor for multiplication and other purposes. So we use this expand columns. So from these operations, expand columns again, operation mean, concatenation. So this is actually, forget about this concatenation, just look at these sequential operations. So you can have an idea that this is nothing but layer normalization, right? So in case if I want to show you some script as well, so that would be interesting. Let me just show you ln.c, and in case if I jump to layer norm forward method, and if I can show you here, you can see we have the initial tensor, which requires grad equals true. Well, I don't want to set, we don't have to set this, but because this is coming from multi-head attention, and this will be automatically set with requires grad equals true. We should not do this, but I was just in this standalone there, so I've just kept it here. All right, so we have mean, tensor mean, we have tensor expand column, we have subtract, we have square root, we have mean again, we have expand columns, fill like epsilon values, tensor adds. So it seems like this is kind of like layer norm, right, happening over here. So this is layer norm. So by the way, I have also generated a graph report for this in order to see if the tensors are breaking or if there is any missing link inside the tensor computational graph, which will obviously these are some things that we have to figure out while backpropagating. But seems like looking at this graph, everything is fine. I'll run the graph report as well for you to show, for you to see that things are just fine and we don't have any missing links, right? So this is basically so this is, you can say, layer norm, and this is concatenation. You know why we concatenate? Because we split the heads of our initial tensor in the head direction, and then we apply scale dot product, and then we sort of concatenate the heads, and this is coming from multi-head attention. So you see this giant block over here, very complex sort of graph, is coming from multi-head attention, and this is something we have a layer norm. So seems like we are connecting the two layers perfectly. Everything is just fine over here. Graph is not breaking, nothing. I mean, you can see each and every link is just crystal clear. So I'm super happy that we've made till here together. I mean, starting this project right from the scratch and see was like it was a huge milestone for me. But for the previous 6 months, I'm just totally into this framework, and things are like like byproducts now, or second nature. So I don't see any difficulties. Inshallah Aziz, will make that happen together. So this is actually the achievement till here so far that I wanted to actually show you. So I've also put this code on my GitHub repo, that is miniTorch. You can search that out. Make sure to give it a star as well, and fork that too. So yeah, this is actually the graph that we have. In case if I wanna show you the graph report, essentially, which looks something like this. Does this? Yeah. So run graph validation, and we don't want to export it for now, because that actually creates a graph for us, which I just showed you. And vim run, and yeah, we're good. Okay, in case if I run this, and you see we have 91 total nodes visited, right? And there is no missing links. We do have null grad at some place. Maybe this is for some leaf tensor, but the important part is we haven't found any missing links, which is like great, which is amazing, right? So using this graph report, we've managed to create a dot file. And when I saw the Kirpathy, under Kirpathy, you implemented this transformer structure from scratch. The hardest part for me was not to implement this, but to create this graph in C, because in C we don't have GraphWiz or libraries like these, right? So I've just somehow managed to create this graph, which is like super amazing. So the whole idea is to create a dot file, and then you can just run a bunch of bash commands to like create that dot file to .png, right? So this was actually the achievement so far, which I wanted to share with you. In case if you want to visit this repo, here is my repo. Make sure to give it a like or star it, and I'll keep on updating this. Right now we have to do stuff for V4 neural network, and then we have layer norm. Layer norm is working just fine, so we are left with only one layer, V4 neural network, and after that our forward pass will be totally ready for AutoGrad with this computational graph. And the only part will be left is, which we have already done some work at, using topological search and DFS and some chain rule. I've actually made the videos on this 3 to 4 videos ago. You can see that. But when I found issues with the graphs, I just reverted back towards this graph implementation currently, and I've just finished to run it successfully, alhamdulillah. So make sure, if you like my content, make sure to give this video a like, and maybe you can subscribe for the future videos, and we will build that together. In case if you have any questions and queries, just keep me posted in the comment section, and I will see you with the next one. Take care.